Hello everyone, welcome back. So in this video, we are going to understand a very important question from the lead code is Q2. I found this very tricky, right? So I'll suggest please keep watching till I will not go to the approach, right? Because I think this is a very good concept, okay? But I will request also, please watch full video as well as give like the video and share with your friends if they are doing preparation, as well as subscribe this channel so you will uh, support expert funda, and I'll keep uploading the best that I can do. Okay, so let's understand from the example here. Very first, understand what we have given, right? So you, for that you have to read the question. What we have given, we have given a nums having length n, we have given, and the nums is the permutation of the numbers in the range 0 to n minus 1. So you may swap elements at indices I and j only if nums at I and nums at j, right, if we'll do the AND, right, is equal to k, where AND denotes the bitwise AND operation, okay, and k is a non-negative integers. So we have to take these checks whenever writing the code, right? First, you may swap two elements. Let's suppose we have to swap the elements at indices I and j. If their AND operation, the bitwise operation, right, bitwise AND operation is equal to k, okay, and k is a non-negative integers. Okay, so as you can see here, we have given this nums we have given, right, and k, you have to assume that this is a non-negative number, means it should come positive value, and so the num we have given, so all the elements, if we'll do the swapping, let's suppose one indices I is at 0, another is, let's suppose for 0 1 2 3, okay, oh yeah, 3. So if we'll do the swapping, it should be the between them, if we'll do the AND bitwise operation, right, it should be equal to k, and k is some value, non-negative value, right? We have to return the maximum value of k, okay, the value of k should be maximum. The array can be sorted in non-decreasing order using any number of swaps. You can do any number of swaps, right? If nums is already sorted, return 0. If num is already sorted, return 0. And further it is saying the permutation is a rearrangement of all the elements of an array, that you know, right? So it is saying if you assume this as example, it will return 1. Why? The explanation is saying that choose k equal to 1, swap nums at 1 equal to 3, nums at 3 is equal to 1, right? If you'll do the swapping, right, what will happen? Because nums at 1 is 3, nums at 1 is 1, since both is coming as a 1, right? So the resulting sorted permutation is 0 1 2 3, and this is sorted, okay, means the value of k is 1. I hope you understands, right? So give me 1 second, guys. Okay, now think about these nums. So target, what is the target sorted array? Target sorted array is 0 1 2 and 3, that you understood, right? Means we have given these nums and we have to this array should be sorted, right? If this array can be sorted, means this is our target. Can we say that? We can say that, right? It is saying if it is already sorted, means we have to return 0. Okay, so can we say that in the very first step, right, we have to understand the swapping rule, right? You may swap nums at some value called at I and nums of some value called j. Okay, now this is the sorted one. Forgive me. Okay, I'll use this one. Okay, so can I use array that is called 0 3 2 1? We can take this array. So this, let's suppose this is your I and this is your j. right? Means nums at I and nums at j, we will do the swapping. So before swapping, you should understand the rule. Means swapping rule is what? It is saying nums at I and nums at j. If we'll do, if it is coming equal to, its result is coming, this is the result, right? If it is equal to coming k, it means we can do the swapping, where k is some fixed value, we can say, for the whole process. Can we say that? For the whole process. Okay. So let's suppose if k is equal to 1, if k is equal to 1, then both number you swap must have the binary representation of 1 bit, right? So if you represent the binary representation, right, of 3 is 8421, so it becomes 0, this is 1, this is 1, and this is 0 0, correct? For 1, this is 1 and this is 0 0. So what is the difference, right? There is 1 bit difference, right? Can we say that? 1 bit difference. If we will take k equal to 2, right, both binary is 1 0 subset of their bit, right? Will happen. If we'll say k equal to 0, right, you can only swap two numbers exactly equal to 0. So these are the possibilities, we can say that. Okay. So what is happening here, when we are going to check the very first position, right, 0, so we'll check the target position. The target position is, it should be how? It should be 0 1 2 and 3. This is our target, right? This is our target. So we'll check this value 0, value at 0 at indices 0, and we'll check as target. Is both correct? Both are correct, already correct. We don't need to do anything. Now we'll check the values, next value, right, at indices 1. But its current index at is where? At 3. 0 1 2 and 3, correct? Next we'll check, is this correct or not? Yes, this is correct. Okay, so we'll say this is correct. Then we'll check value at here. Its index is what? At 3. It should be here, right? Like this. Means we saw that index 3, it should be at index 3 and it should be at index 1, right? Means say index 1 should go to index 3, index 3 should go to index 1, right? So that is a one cycle. Means very first cycle is 1 should go to 3 and this 1 should come to where? At here. Can we say this is a cycle, one cycle, right? Means if we say the cycle will look like how? 1 3 1. So this will be like a cycle, right? So why we choose k equal to 1, that you understood, right? So when we taken 0, we clean it here. Okay, so when you take binary form, right, when it is 0, you take 0 0. When you take 1, it will become 0 1. When you take 2, it will become 1 0. When you take 3, it will become what? 1 1. If we'll say k is 1, right, can there be a condition? Condition is what? A and b is equal to 1. Can we say that? Right? This means both a and b, 1 bit difference we have is 0 1, right? And that is why we can say we chosen this place, right? So if we'll take like this, let's suppose 1 for 0 bit, what we will do? 0 1, right? And for this is your 3 and this is what? 1 1. So if we'll take this, what is coming? 0 1 is coming, right? So this is your 1 bit difference, and that is why we have chosen k equal to 1. So when it is coming 0 1, means we can say that the cycle is between 1 and 3, right? The cycle is how? 1 and 3. So what we can do? We can swap directly. We can swap directly. We'll not do anything. We'll just do swap, right? So like that, if you found that, right, where first you have given some array, right, means before sorting and after sorting, right, you check the things, you will find the cycles, right? Once you find the cycle, is that from 3 to 1, if and is coming, what is coming 1, right, it means what, we can do the swapping, right? You will find the indices I and j, you will find, and you can do the swapping, right? Okay, so you can also say that why this k equal to 2 fails, right? Let's suppose for binary 2 equal to 1 0, so only number contains bit is what, 2 bit, and that can be swapped. So if we'll say number is 2 is 1 0 and number 3 is 1 1, right? But in our cycle is what, 1 to 3, this is our cycle. So number 1 doesn't have bit 2, and then can't we move, right? This can't be moved, understand? So this is the problem. So what is the intuition? So for any k we have, right, for any given k, numbers will take what, nums and k, nums and k operation will do, right? If it is equal to k, right, that will form a connected component in the graph. Okay, so this is the rule, right, that can form a connected component in the graph. If any array we have given and any number if we'll take, right, and that number k is equal to k coming after the AND bitwise operation, right, it will form a connected component in the graph. So you can rearrange the value freely with each connected component, but you cannot move the value across the component. Okay, so if we understand the sorting is possible or not, so sorting is possible, right, if for both each connected component, right, the set of values currently in is where it can be rearranged into the set of values that should be in the sorted order, right? So let's understand the approach. So very first, what you should do, right? First we will find the target, right? Target order. How? Do the sorted nums. Can we say that? Then test k values that we have done, right? Why? From largest to smallest, if it is possible. Okay, then for each k, what we should do? For each k, first we'll check what, the group indices into connected component based on the allowed swap, right? What we will do, we'll do group indices into, we can say, connected component, right, components based on allowed swap, understand? Then in the next step, what we will do, we'll check if each components can be rearrange to match the target. Can we say that? And then in the fourth step, we should return the largest k that works, right? That this is the approach we can do. What we will do, very first we'll find the target order. How we'll do that? If we'll do the sorted nums, the nums that we have given, we'll do the sorting, right? Then all the k, we will do the testing of the k values, right? If we'll test all the k values, right, that we can get from where, from largest to smallest possible values, right? After that, for each value, right, what we need to do, first group the indices into the connected components, right, based on the allowed swap that we can find, right, through the INJ. Then we'll check if the component, each component can be rearranged to match the target or not. If it is matched to the target, we are good. Then finally just return the largest k that will work, because we have to find what? Largest k, right? And that is our statement we have given. Okay, so let's understand how the code works. So very first, as you can see, let me zoom a little bit. I have added the code from the Eclipse. Okay, so very first we'll do nums dot length, right? And then we will do quick sort to check, right? We'll take a boolean sorted, right? We'll check is this a sorted or not, right? If it is sorted, so we'll do quick check of the sort is sorted or not. If it is sorted, it's fine. If it is not sorted, then we'll do the sorting. But before that, first of all, what we should do, we'll check sorted. If it is sorted, we'll return 0 because the question is saying, right? Now what we should do, it means that the required thing we will do means we'll do the variable, and the pre-checks we will do till that. Okay, next what we should do, think. So once you got, let's suppose we have the max value is what we have given is 3, right? Means the largest value in the nums. What is the largest value in the nums? We can get from here, right? So we'll say max value is 3, let's suppose, or you can say n minus 1, that we can get from the here. Okay, then we'll take a b. B is the number of bits that needs to be represented for the max value, right? And for that you can represent, and you will increase b plus plus, means how many bits we require? 2 bits. If max value is 3, how many bits we required? We require 2 bits, correct? Then we'll do what? Full masking, right? So we'll take the full masking, b equal to 0, right? We'll check 1 is a 1 shift of b minus 1 will do, means we will get binary value, will get what? How many? We'll get binary value is full mask of 1 1, correct? For the bits 2. Then we'll check the position of each value, right? It means we want to build the POS, right? Means the position at v, let's suppose some value is there, is, let's suppose the position at some value is there, right? Is a index value that v is located, value v is located, we can say. Okay, means position at I is a, you can say, the index where value v is located. Can we say that? Then we'll update the position at nums at element, means position at nums at element means this is the index element. We will store the index, right? And where value is located. Understood? Now let's suppose for all the nums we have 0, 3, 2 and 1 was we have given, right? Means 3 and 1 we have to swap, right? So very first we know that position at 0 is 0, position at 1 is 3, position at 2 is 2, position 3 is 1. Can we say that? Like that we have given. Then we'll check the this condition, means we want to compute the AND, right? So you know how to compute the AND. Just you will take the full mask that we have calculated here. We'll check if it is any miss is there, right? And then we'll loop through each value. Then we'll check the conditions. If v is equal to 0, right? Or position at 0 is equal to 0, means correct position we have. We don't need to skip, right? We will skip, sorry. If it is not equal to 0, right, means we will calculate the value, right? And you will do the calculation. So let's suppose position at 0 is equal to 0, means that is correct. We'll skip that. Let's suppose position at 1 is coming 3, right? That we have seen in the array, right? Means it is wrong. We'll do the it's a miss and, right? If we'll do miss and, means we'll take 1 and we'll take what? 1 and we'll take the AND of operations. Let me how. So try to understand, okay? What we are trying to say, we have seen, right, the value at 0, I was saying it's a pause, right? Pause at 0. Can we say that it is 0? it means what? This is correct, right? We will, if it is correct, we will skip it, right? If is equal to 1 means position at 1 is what? We are getting 3, means this is not correct, means we will apply the and miss, right? How? We'll take 1 1 1 and 0 1. What it will come? It will come 0 1, right? It is a binary one that we have seen, right? Binary one, because it is not coming 0. Then we'll take what? At 2, POS at 2, what is there? It is 2, means we will skip. It is also correct, right? Then we'll check at 3. So POS at 3 is what? 1, means this is not correct. This is wrong. It means we will apply here, like how? 0 1 and we'll do 1 1, sorry. 3 is 1 1. Okay, so it will come 0 1, means this is also coming 1, this is also coming 1, means we will apply with the AND. If you apply with the AND, you will see it is coming 1, means both we have to replace it. Means this means any k must be with the mask of 0 1 bit. Position k value is 1 and 0, right? Then we will try from the largest to the smallest one. Okay, so further how we are going to try? You will take that, let's suppose 0 you have tried, you will try 1, like that you will keep trying, right? So we have further, let's show you here. So once you will try, right, what you need to do, you will keep checking. If any miss is there, return 0. Otherwise iterate k over mask of and from the largest to a smallest one, right? Means we want to try them from the largest to a smallest one, right? So we'll try k equal to 1, right? So how we are going to do that? Let me show you how. So let's suppose we have this value. Let's suppose, can I say this mask R for now? We'll take the full mask, right? And we'll take k. It means this is what? 3 we have, and k is nothing but 1. We are trying k equal to 1 here. Okay, it means this is your 1, right? So it will come, this is 1 1 and this is 0 1, correct? It will become what? Binary of 0, not 0 1, sorry, it will become 1 0. Okay, it will become 1 0. Okay, it means mask R means it's a bit outside k, correct? So what we will do, we'll prepare present mask. Will present mask will be there, present at mask. So present at mask is what? Where there exists a value with the value and k is coming equal to k, and extra are nothing but a mask. Okay, means we want to prepare the present at mask, right? And that is nothing but it will store the value with this one, right? And extra, you can say. So value of mask will store what? Let me show you here. So that will do here checking. We'll check the candidate k that is allowed for sorting. Okay, so we'll keep adding here line number 51 and 52, you can say, right? Value of mask will store the actual value. Okay, as you can see here, this will store value with the present value, will mark this value is existing value at value and k is equal to k is coming, means it is true, and it's have an extra mask, right? Then what we will do, we'll apply value of mask is equal mask, it is a mask that will store the actual value, means store the value, right? Otherwise in the else condition will fill the present value, right? But for that, what you need to do, we check if the value is not equal to v, will return false. Means we want to fill all the value here only if it is condition matching. If condition matching, then we'll take with the value and will the mask, right? Means with the extra mask, whatever the value is coming, that will take and will store here. and will present at m will mark a true. So each time what we will do, we'll check this 0 and 1 is not equal to 1. We'll skip that, right? We'll check 1 and 1. Okay, allowed. Mark it 1. Then we'll add 3 at 1. Similarly, it will take 1. But 2 at 1, it will not mark. So we'll skip that, right? So like that, at present at 0 and present at 2, it will be marked. Means value 1 and value 3 will be marked true. Okay. And rest of the thing, we'll do the BFS that we know. You know how to apply the BFS. BFS is a component, right? For the component, we will visit unvisited mask in the present, and for that basic template we will apply this one. Means first of all, we'll mark the value that we are going to use here, right? And we'll take a Q, and the what you call component value will keep adding here, right? And for that, let me zoom out a little bit. So very first, what we need to do, we'll start the component starting at mask 0, means value 1, right? So Q is 0, that will take right here, and target we will take this one, right? So we'll start 0 to m. M is from 0 to the size. We'll check if it is not marked, right? It is not true, present is not true, or it is visited, just continue, will not do anything. Then we'll apply the BFS to collect all the component mask. So what you need to do, we'll take the value Q and tail will take, right? And we'll find, we'll take the very first, we'll mark it as visited. We'll take the number of component, we'll keep increase the component. We'll check head is less than tail, right? And this complement will find like this, and we'll iterate over the component, right? We'll check if both are present and not marked visited. We'll mark it visited first. We'll increase the Q tail plus plus. Will increase the component plus plus. Like that we will do. Okay. Then we'll mark the value in the component like this. Okay. First, then we'll verify the value, the target value, and we'll keep checking for all the value. If it is marked value is not marked at that position, clear the marked, that is failed, right? And you will check from I because I to Z we have to check, so you will check the value, and then it will return false. Then we'll clear the mark for the next component like that. Means we'll keep doing that. So if you are aware with the BFS for the connected component, it is easy for you to do that, right? Because very first we'll check the component starting at mask 0, that for the value 0. So we'll add on the Q at 0, you will add, right? And you will take the component, right? How mask R, and we'll take the component at 0, right? So we'll take 2, the operator you will write bitwise operator, and it will become 2. Like that, we'll keep going that, right? And you will check the unvisited marks, right? So that is means the unvisited marks is present in the V. It is unvisited, right? It means we have to continue checking the BFS, right? And we'll collect this mask component, that is mask, right? We'll keep doing that. How we'll going to do that? Like this, you will apply these formulas, right? That we have done. Very first, you apply, take the complement, right? Means let's suppose this mask is your 2, and this is current is 0. How many will get? We'll get 2, right? Then you will check for all the submask, right? Let's suppose submask of 2 is 2 and 0, right? The very first 2 is present in 2. Yes, it is true. Then what we will do? We'll add this mark to the Q. So you will add it into the, we will mark into the Q. If S is 0, right, means already visited. Don't do anything. Then you will check again. Now in the queue is what? Previously it was 0, now it is 2. Then process again. This loop will keep continuing that, right? You will find the complement again that we have done, right? We have find the complement. Then you will find the mask, right? You will find the mask, and then you will keep doing, you will keep repeating this, right? Once you will find 2 and 2, right? Mask R is 2 and this is 2, current is 2, means become what? 0. Means submask of 0 will find it is present, already present, will visited is. Okay, so the finished component is become what? How many? It will become 1 and 3. So we'll say component is become 1 and 3, right? Then you are marking all the things, all the value in the component. Okay, so you will check the target, means we mark the value 1 3 in the component. So we'll check that. How will check that? We will mark the value 1 3, right? So we'll check value is 1. Let's suppose we are getting the value here. If value is target equal to 1, is index 1 value is in 1 and 3. So we'll check if we are seeing that value, if position at 1 is in the component. Yes, it is position at 1 equal to 3. So this is in the component. So we'll say, okay, we are good, right? If it is not, we'll update is false. Okay, if it is that, means update is, will mark it as a false. Okay, means all are good now. Let's suppose we are good now here, right? Means there is no mismatch is there, all works fine, means we will return true. Okay, I hope you understands. Thank you guys. Let me know in the comment section that you understood or not, but I'll try to summarize in the comment section so you can get from there. Okay, if you have any doubt, let me know in the comment section and I'll definitely help you there. I'll see you in the next one. Thank you, and please like, subscribe this channel so I can give you my best. Thank you.